Good morning, everyone. I am Wong and is a lead safety engineer for our new mortar production facility. We are currently at a critical junction in the design phase. Today, I want to discuss why we must move beyond traditional add-on safety measures and insist build safety in from the ground up. My goal is to secure management support for investing in inherent safety principles to ensure our plant is not only productive but fundamentally safe and resilient. In our industry, the most significant risk we face during the design of a mortar plant is compatible dust explosion and chemical exposure. Cement itself doesn't burn, but organic polymer and cellulose ether used to enhance mortar performance can swarm explosive cloud within high-speed mixer and dust collector. If we don't address this in the plant layout and equipment selection now, a single spark cloud can lead to catastrophic event resulting in structural failure, total production loss, and most important, worker failure. Long-term chemical exposure can lead to chronic health issues. This is wet line production facility. Mainly is a manual. Therefore, we will be implement atmospheric control and moderation. Produce is called mortar production facility, which cover about 80% total production output. This is offline process, mainly focused on a niche and custom-made additive or premium product to specific customer. This process is semi-auto. My proposal on inherent safety solution. First, on wet line, mainly go for atmospheric control or moderation, moving from an open manual process to a mixing chamber designed to operate under controlled conditions. By ensuring the mixing chamber is properly sealed and potentially inert, these are eliminating the oxygen and dispersion required for a dust explosion. The second item is softened automated dosing, or we apply the simplification solution. Raw material from silo 1 to silo 9 are discharged via automated wing hopper. Wing hopper P1 according to a preset recipe. This reduces human exposure to crystalline silica and chemical additive, addressing the health issue identified in the report submitted. The third one is on overall facilities. We implement control operating parameter. First, on flow speed, material flow is strictly controlled between 20 to 70 hours to reduce static electric build-up. The second is variable mixer speed. The system uses auto selection for mixer speed, ramping from 30 Hz to 50 Hz. This prevents the high energy friction and heat that could trigger an ignition event. The third one is buffer management. Using a buffer tank with a 15 minutes discharge time allows the material setting, which prevent airborne dust cloud during the packing phase. Last but not least, to discuss business and safety justification while investment. Cost avoidance through design. Integrating a 3-meter high mixing drum platform and automated wing hopper can avoid the massive future cost of retrofitting the plant with secondary explosion suppression system. It is significantly cheaper to engineer a safe layout at the start than fix a hazard after an accident. Second, operational reliability. Our simulation show material flow speed strictly controlled between 20 to 70 tons per hour. This isn't just for efficiency but critical safety parameter that prevents static electricity build-up, which is a leading cause of dust ignition in mortar plant. Third, regulatory and reputation protection. Adhering to this design standard ensure compliance with OSHA 1994 and the ATEX Directive for Explosive Atmosphere. Beyond avoidance fight, this protect company from irreparable brand damage and legal liability follow a major industry disaster. Fourth, long-term risk reduction. The transition from manual dosing to PLC control system remove the highest variable in our risk equation, human error. By automating the recipe and setting the mixer to ramp between 30 to 50 Hz, we ensure the plant operates in safety envelope every single day, regardless of operator fatigue. Thank you for the attention and looking forward positive feedback management.